Okay, we have seen a little about how ions are formed, or what are ions, or what is ionic bonding. We've started studying about ionic bonding. Let's see, how do ions look like, or what actually happens, or how can we represent ions, or what is happening at the atomic level, what is happening at the electronic level, or the at the level of electrons during ion formation. This over here is a sodium atom. This is the electronic structure of sodium atom. You can see it has 3 electrons, and because it is in group 1, it has only 1 electron in its valence shell. The electronic configuration is 281. 2 electrons in the first shell, 8 electrons in the second shell, and because it is in the first group, it has 1 electron and its valence shell. Alright, sodium has a proton number of 11 and a nucleon number of 23, which means that it has 11 protons, 12 neutrons, and because atoms are neutral and atoms have protons and electrons equal, and it also has 11 electrons. Alright, number of protons is always equal to the number of electrons in an atom. Alright, you can also count the number of electrons, which are 1 2 3 4 5 6 7 8 9 10 and 11. Alright, 11 protons, which is the atomic number, and it has 11 electrons as well. Now this over here is the valence electron. These valence electrons, these are always involved in the bonding. Alright, only valence electrons take part during bond formation. This is important, you must know. Only valence electrons take part during bond formation. Okay, now it has one valence electrons. Now it wants its valence electron to be complete, or it wants its valence shell to be full. So what it can do, it can either gain 7 electrons, or if it loses this valence electron, then this shell, the second shell, will become the valence shell, and you can see it has 8 electrons in its outer shell. Alright, so it is already full. So sodium, it is easier for sodium atom to lose this 1 electron rather than it gains 7 more electrons in its valence shell to complete its octet. Alright, so what sodium will do is, sodium will try to get rid of this 1 electron so that its valence shell is complete, so that it can achieve its dream configuration. Alright, so sodium loses 1 electrons. Alright, sodium loses its valence electron, and then it is left with only 2 shells. Alright, third shell is gone. Third electron is gone, and there is no such thing as an empty shell. Alright, shell is just a path of electron. Alright, there is no physical presence of an electronic shell. It is just an orbit. It is just a way. It is just a road on which it is just the directions in which this electron is moving. Alright, there is no physical significance of a shell. There is no such thing as a shell. It is only a path, a direction in which this electron moves. When an electron is gone, when that means there is no more shell left. Alright, so when this electron is out, the sodium is now left with this 1 and this 2, these 2 shells. Alright, sodium now has only these 2 shells, which are shown over here. First shell containing 2 electrons, second shell containing 1 2 3 4 5 6 7 8. Octet is complete, sodium is happy, but there is one thing, that because this electron is lost, now the number of electrons, it has become 10. Alright, number of electrons is now 10. Initially there were 11 electrons. Now because 1 electron is lost, number of electrons is 10. But you must notice that number of protons is 11, and it was 11 initially. Number of neutrons was 12 and now it is again 12. Only number of electrons has changed. Alright, now number of protons are 11 but number of electrons are 10. So number of protons is greater than number of electrons, which means it should have positive charge. It should have a net charge of positive 1. Alright, because there is one more proton than electrons. Electronic configuration is now the best it can be. It is 2 8. Valence electron last shell now has 8 electrons. It is now full. Now when it loses an electron, it gains a positive charge. We represent it by these brackets. Alright, we add these brackets and we add the net charge that is gained. Alright, which is positive 1. We do not need to write 1. Or if it was 2, then we would have written 2 over here. But if it is 1, then we can only write positive. This is how sodium loses an electron and it becomes a sodium ion. Alright, now this sodium ion has its valence shell complete. Alright, it has 8 electrons. Now this is the noble gas configuration. The octet is complete. Alright, that was the dream of sodium, to complete its octet, and it has done it. Alright, so let's move on to another example. Now I've drawn these electrons with a cross. You do not need to worry about it. There is just a representation. You can draw it with circles, you can draw it with cross. These are usually this is a convention where we either represent electrons with circles or with these crosses. They mean nothing. These are just indication. You can draw them with a heart as well, or you can draw them with a star as well, but the convention is this, or we either use a dot or we use a cross. Alright, so let's see what happens in a chlorine atom. Chlorine atom has 1, 2, 3 electronic shells, and you can see the number of valence electrons. We're counting valence electrons because you must know valence electrons are involved in the bond formation or in the chemical reactions. Alright, so how many valence electrons are there? 1, 2, 3, 4, 5, 6, 7. 7 crosses means 7 valence electrons. It's very close to complete its octet. Alright, it needs one more electron to complete its octet. Alright, to complete its dream configuration. Have a look at this detail. It has 17 protons, 18 neutrons, and it must be electrons. 17 electrons. Alright, 17 protons, 18 neutrons, 17 plus 18 is 35. 35 nucleon number and 17 electrons. Alright, so number of protons is equal to the number of electrons. You must see 17 protons and 17 electrons. That is why an atom is neutral. Chlorine atom is neutral because number of protons is equal to the number of electrons. Electronic configuration is 2, 8, 7. 2 in the first shell, 8 in the second shell, 7 in the third shell. It needs one more electron to complete its valence shell, to complete its octet. Now, how will it do it? Let's see. It will gain one more electron to become chlorine negative ion. Look at what happened over here. Now, this is drawn by a dot just to represent that this is the external electron that came into chlorine atom. Alright, now because this additional electron is added, chlorine will add these two brackets and will add this negative sign, which shows that one electron is gained, which shows that there is an additional negative charge. Alright, now this one electron is added and number of protons is same, number of electron is same, number of protons is same, number of neutrons is same, and the number of electrons has increased from 17 to 18. Initially, there were 17 electrons, now there are 18 because one more electron has entered into the valence shell of chlorine atom. Now the number of electrons is more than the number of protons. Number of protons is only 17, number of electrons is now 18. There is one more electron which results in this additional negative charge. Alright, because electrons are now more. There is one more electron, which means one negative charge. Alright, but the electronic configuration is now happy. That is 288. 8 electrons in the valence shell. Valence shell is full. Octet configuration. Congratulations, chlorine. You've done it. Alright, let's see another example. Oxygen. It has 8 protons and 16 nucleons, which means 16 minus 8 equals 8 neutrons. Alright, have a look at its electronic structure. 2 electrons in the first shell, 1, 2, 3, 4, 5, 6 electrons, and its second shell electronic configuration is 2, 6. It needs 2 more electrons to complete its valence shell. Alright, it has 8 protons, it has 8 neutrons, it has 8 electrons. Number of protons equal the number of electrons. Alright, so the electronic configuration is 2, 6. 2 more electrons needed to complete its octet. Alright, so what will this do? This will gain 2 electrons which are represented by these crosses just to differentiate from these original electrons. Alright, now because 2 electrons are being added, that is why there will be a net charge of -2. 1 electron carries a net charge of -1. That is why we'll have a net charge of -2 because 2 electrons are being added. Alright, and it will write it as O minus 2 because obviously 2 more electrons, and oxide ion is O minus 2. Now look at what happened to this proton, neutron, electron. Number of protons and neutrons is unchanged. Nucleon number is still the same, but electrons have increased from 8 to 10, which means that 2 more electrons have been added. Alright, that is why the number of electrons is now more than the number of protons. 8 protons and 10 electrons. There are 2 more electrons than the number of protons. But look at what happened to electronic configuration. From 2, 6, it has now changed to 2, 8. Octet configuration has achieved. Alright, noble gas structure. It is the same as neon. Alright, so now oxygen has successfully completed its valence electron. Let's move on to one more example. What happens in case of magnesium? Magnesium has 1, 2, and 3 electronic shells, and it has 2 electrons and its valence shell. You can guess its group number. It has to be in group 2 of the periodic table because it has 2 electrons in its valence shell. Now what magnesium needs to do is magnesium somehow needs to get rid of these 2 electrons so that the shell that is left behind, it becomes the valence shell, and it is already full. It already has 8 electrons in it. Alright, so if sodium somehow get rid of these 2 electrons, then it can achieve the noble gas configuration. Alright, this magnesium atom has 12 protons, 12 neutrons, and 12 electrons. Number of protons and electrons are equal in magnesium atom. Alright, all atoms have equal number of protons and electrons, and electronic configuration is 282. This 2 is not what magnesium needs. Alright, magnesium needs 8 electrons. The third shell has the maximum capacity of more than 2 electrons. Alright, so magnesium wants this to become its valence shell. So magnesium will get rid of these 2 electrons. How? Alright, here is how. Magnesium donates the 2 valence electrons, alright, and these two shells, 1 and 2, the second shell now becomes the valence shell, and it is already full. Alright, you can see over here, second shell has 1, 2, 3, 4, 5, 6, 7, 8 electrons. That is what magnesium needed. Now magnesium has 8 electrons in its valence shell, and its nucleon number is the same. It has 12 protons and 12 neutrons. Number of electrons is reduced from 12 to 10. There were 12 electrons, now there are 10 electrons. The number of electrons, oops, the number of protons is now more than the number of electrons. Alright, so a number of electrons is now less and number of protons is now more. That is why magnesium has a net charge of positive 2, because 2 electrons are less than the number of protons. There are 12 protons, that means 12 positive charges, and there are 10 electrons, that means 10 negative charges. So there is a net charge of plus 2. Alright, so this is now the electronic configuration 2-8. Electronic configuration, the desired electronic configuration, the dream electronic configuration has been achieved. That is how magnesium becomes a magnesium ion. Alright, Mg becomes Mg2 positive. Now this, yes, this is important. You must see how 8 electrons, the shell is gone. Alright, let me draw this again. Okay, good. Now, there were initially 3 shells, 1, 2 and 3, but after the ion formation there are only 2 shells, 1 and 2. Alright, notice how the size of metals decreases and nucleons remain the same. There were initially 3 shells, now after the ion formation there are only 2 shells, which means that the size of metals, it decreases when ions are formed. Alright, this is not the case in non-metals because they add electrons in their existing shells. Alright, there were 6 electrons and 2 shells, and then there were 8 electrons, but the number of shells was again 2. It was unchanged. Similarly, in case of chlorine, there were 3 shells in chlorine atom, and again there were 3 shells in chlorine ion. Number of shells was not changed. Number of shells in sodium also changed because sodium is a metal. There were 3 shells, and after ion formation number of shells became 2. Alright, which means that the size of atom has decreased in the case of metals. Alright, this is important. You must know that after the ions are formed, metal atom, it decreases in size to become the metal ion. Alright, and the number of nucleons, it remains the same. There is no change in the nucleus. Alright, only electron transfer takes place. Only valence electrons are involved in the bond formation. Rest of the atom, rest of uh, whole structure, it remains same. That's it for now. I'll see you in the next video.